Hey guys, today we're going to make sense of something that shows up in every coding interview: time and space complexity. It might sound hard, but by the end of the video, you'll understand it clearly with no confusion. So, let's start by seeing what is time complexity. So, time complexity is defined as the amount of time taken by an algorithm to run as the length of the input increases. So, it tells us how long your code takes to run when the input gets bigger. So let us see a quick example. We'll create a list with 5 elements. So we'll start by adding an element: 2, 4, 5, 8, and 7. So this list contains 5 elements, but what if it's 5 million? Time complexity helps us guess how much work the code needs, not in seconds, but how the steps grow. We write this using something called the big O notation. Let's go over some common ones. So here we have some common types of time complexities explained simply. So first we'll start with O1. It stands for constant type. It's super fast and it doesn't change with the input size. For example, getting an item from a list. Second, we have ON. It grows with the size of the input. Example, looping through a list. Third, we have O n square. It is slower, often from loops inside loops. Example, checking every pair in a list. Then we have O log n. It is very fast. It is used in smart searching like binary searches. Lastly, we have O n log n, used in fast sorting methods like merge sort. The smaller the big O, the better your code performs on larger outputs. Let's take a quick example. Consider we have a phone book. Phone book is what we store our name and contacts in. So if we need to search for a specific name in a contact book, what we can do is we can either start by searching from the first page, like each name, that is considered your O N. But if we flip our phone book to the middle and then start searching, that is considered O log n. This is usually faster and used for finding an element more efficiently. Let's talk about space complexity. So, space complexity is the total space taken by your algorithm with respect to its input size. So, it tells us how much extra memory your code uses. If your code saves extra things like new lists or makes a lot of recursive calls, it's using more space. So just like time complexity, here we use the big O notation, and it consists of things like O1, ON, and so on. So in space complexity, O1 means no matter how big your input is, memory use stays the same. Now let's take a look at some examples. So the first one is a simple loop printing a list. So that is ON time and O1 space. Second, we have two loops comparing everything. So that is O n square time. Third, we have a recursive Fibonacci series. That is O 2n time and O n space. Lastly, we have a fast Fibonacci series with memory. So that requires a faster time but a larger space. So sometimes you need to make a trade. To save time, you need to use more memory or the other way around.